Welcome everyone. This video series is intended to introduce you to finite element analysis using ANSYS, and here we are. We are going to start with static structural because that's probably the most familiar to most of you. So we will drag the static structural and drop it into our project schematic, and that will create a static structural analysis object for us. And you will notice we can define engineering data, geometry, model, and eventually we will get to results. So we will start off with engineering data. That's where we define our material properties. So let's just double click on engineering data, and we can see that it lists all the material that have been defined and their properties are defined here. Now we start Now to start, automatically populates uh, this structural steel. So we are just going to leave it like that. In a future video, we will talk about how to define a new material. So for now, that's good. Let's close out of this tab. Brings back to this schematic here. Here, the next thing that we will want to do is check our geometry. So right now we don't have any geometry. If you right click on geometry, there is a couple of options. You can import geometry if you are proficient, let's say in SolidWorks. You can build a 3D model and bring it in here, or you can try your own geometry in Ancestry program called Space Climb. So let's just use Space Climb. Space Climb is opening up now. Space Climb is the built-in modeling software for ANSYS. You see here our modeling space. The first thing I'm going to want to do is select my units. So if we go to File, it's basically options, and make sure that units are in metric and millimeters by default. So I will say okay, and now I will be modeling in the metric system. Uh, for this problem, I want to define a beam and it will be 2 meters long. So I want to first select my sketching plane. So I will select the XY plane. So if you move your mouse, you can see that you can select a different sketch plane. For this problem, I will select the XY plane, and then I will click on a plan view. So now I'm looking at the plan view. I'm just gonna make a rectangular beam, again 2 meters long. So I will click here to rectangle to make a rectangle. I will click in the origin, and the blue number of the highlighted on the bottom I can type, for example, 2000 millimeter, and hit tab, and by hitting tab it will go to the other dimension, and that I can specify, for example, 200 millimeter, and that will be the 200, the 200 millimeter deep, and hitting tab again and then enter, and we will enter your beam in, and so that's going to be my beam section. If I click here on return to 3D mode, that will exit sketch mode, and now I have a 3D shape. So right now it's just a plane. If you if you want to navigate around, you can use the middle mouse wheels, and if you click in the middle mouse wheel and turn, that will rotate, will rotate the plane. So it's control on the middle mouse wheel. And for zoom in and out, if you just scroll on the mouse wheel, that's zoom in and out. So again, right now I have just a plane. So I want to give this plane some depth. So the pull command will be used to offset or extrude a face. So I'm going to select this face. I'm going to click on this arrow and I'm going to pull it out. And again, it has that number highlighted in blue. So I will choose, for example, 100 millimeter thick. I will, and after that, I will hit enter. I have extruded 100 millimeter and I will hit escape out of the ball tool, and now I have and now I have my beam. Now the last thing we want to do is define a loading service for this beam. Let's assume the beam is loaded at mid-span with a point load. In practice, applying an exact point load in a finite element analysis is not ideal. So instead, we will approximate it using a small surface batch at the mid-span. To create this batch, we can split the face of the beam. So go to design and select split, and then choose the face that you want to split. Then move your mouse along the edge to specify the split location. First, split the face at a distance of, for example, 900 millimeter from one end, and next split the same face again, this time measuring, for example, 200 millimeter from the opposite side, so that you define a small region at the center of the beam. So if you just need to switch between input boxes while entering values, just press tab and press after that enter to confirm the command. So that completes the geometry setup. Once you are finished, you can close the basic line. Saving is optional. If you want to save the geometry, you can save it only like if you plan to reuse it in other models. But even if you don't, it will still automatically transfer into ANSYS workbench. And now we are back in the workbench. You can see my geometry has been updated. As the check mark there, it's complete, and the model now is ready to run. So this is actually where you do the analysis. So let's double click on model, and that opens up mechanical. So mechanical is opening now. As you can see, my geometry is attached here. I have a solid object here consisting of a single part. Normally, if your model contains multiple parts, they would all be listed here. So So looking at the properties box, you can see that the material assigned is structural steel. This assignment has already been done automatically. If I opens the materials tab, you will also see that the structural steel is listed there. Again, this was pre-assigned, so I didn't need to define any material properties myself. And in this case, I'm not modifying any of these properties. So our material setup is complete. Next, we move to the mesh. So to set up the mesh sizing, we click on mesh and insert sizing, and to define the geometry, we click on the body and hit apply, and then we define the element size. We put, for example, 50 millimeter for the element size, and now we click on mesh and generate mesh. Now we generate mesh. Next, we will define a static structural. So let's click on static structural, and then we will define our boundary conditions and loading. So we will add fixed support to this face and hit apply. And we will also add fixed support to the other face and hit apply. And we will add a loading. We will add force to that, and I will use the component because the force, it will be pushing down in the y-axis, so it will be negative 20,000 Newton. So 200 and then we will solve. So I hit solve. Oh, I forgot to add the solution results, that I can add deformation, total deformation, stress, equivalent, or normal stress, and I can see the results. So the results, the solution is solving now. So the solution is solving the solve. As you see, I added total deformation, and also I added equivalent stress, and I will solve the solution. And now you can see the results of the total deformation and the stress, as you can see. And that's for today. If you like the video and subscribe, and thank you.